Hi, my name is Sachinda Seranayaka. I am from Gateway College, Colombo, representing Sri Lanka, presenting to you my project for the APICTA 2021 competition, the Calorie app. So, to understand what the Calorie app is, we first need to understand the term obesity. Obesity is a noun which describes a medical condition in which excess body fat has accumulated to an extent in which it causes a negative effect on your health. Now, obesity is simply a 6-letter word, but it affects more than 650 million adults based on a research that was done by the World Health Organization back in 2016. But what is the main cause of this? It is simply an increased intake of energy-dense foods such as those that are high of fat and sugars. Now, talking about energy is a quantity measured in joules, and in food, energy is defined in terms of calories. So what exactly is a calorie? A calorie is the energy quantity required to raise the temperature of 1 gram of water by 1 degree Celsius, and this energy value is approximately 4.18 joules. Now, one thing we do have to note is that calories depend on the food, so different food items have different calorie values. But how do we at our dinner table find out quantitatively how much we are eating? To this I have the answer. Let's take a look. Calorie is the application that I've presented to the APICTA 2021 competition, which uses machine learning and AI to detect calories in food. How exactly does this work? This application is based on the masked region-based convolutional neural network, which we simplify as just mask RCNN, which performs object instance segmentation, which is basically finding out how many of a particular type of object exists on a given plate or a given image. Now, what I did was I trained it to detect 12 classes of Sri Lankan or local food, which is also listed on screen now. First of all, take a picture of your plate of food. When you do this, make sure that the camera is vertically above the plate of food, and make sure that you have the calorie reference object next to the plate of food in order to take measurements which will be used later on in the calculation. Once this has been done, open up the application, and you start off by clicking on calories on my plate. Once you do this, you will be asked to select where the picture of your plate is. The picture will now be loaded onto the application, and click on continue to proceed. After a few seconds, it will detect 2 objects on this plate of food, but here what you got to do is select the reference object based on the number that is displayed on top of each object detected. So the reference object is the first object and the plate object is the second object, and then it will ask you to specify the size of the reference object. Since the reference object is a common object that we supply along with the application, it is given a reference of 40 millimeters in size, which is also set to the application as a default value. Upon pressing continue, it will now estimate the dimensions of your plate of food, and here it tells me that it is 24.53 centimeters. If you take a look at the actual size of the plate, you will get to see that it is approximately the same as the one suggested by the application. Once that has been done, you will see bounding boxes and a total number of calories that have been detected by the algorithm on your plate of food. Of course, there are some anomalies because it requires more training, but as you can see, it has detected 2 pieces of food correctly, that is red rice as well as dal curry, which are 2 local food items which we consume back in Sri Lanka. The value here, my calories, is something related to the second option that you find on the application, which is the daily calorie intake value. When you click on this, it will ask you certain details such as your height, mass, gender as well as your age to calculate your daily calorie intake as well as your BMI. So how exactly does the application work? Once you supply the image, it will first detect objects on it so that we can select what the plate and reference object are. Once this step has concluded, it will now move on to isolating the reference image. After this, it will tell you the calculated width of the plate, and this is done by taking the reference object's actual width divided by the reference object's pixel width multiplied by the plate object's pixel width. In the next step is where you have the most important part. It runs the MRCNN network, which queries the trained neural network by supplying this image that was sent in by the user. The technologies used in this are Godot Game Engine for the UI and graphics. For the machine learning scripts, I used Python along with scikit-learn and TensorFlow modules. And for training my artificial neural network, I use the Google Collaborative. As future improvements, I'd like to remove the use of a reference object so that the user just needs his or her smartphone. And I'd like to port this application directly to Android so that we can have access to the native camera, and increase the mask RCNN's prediction accuracy by using a minimum of 50 sample images per class. And furthermore, I've also currently implemented the Android app, and it is currently in development, and I've done this via Apache Cordova. That concludes my presentation of the Calorie application. Thank you.